This is the question regarding the finding the relationship among the velocities of the blocks A and B for figure A as well as figure B, and which is under the given constraints. So these are the constraints which are given, and we are supposed to find out what will be the relationship between the velocity of mass A and velocity of mass B in A and B part. So in this case, let us start with figure A. Figure A, let us assume that the mass B moves up by distance x with the velocity Vb, and its velocity is Vb rather, and let us name this pulley as x, and because of x distance being moved, so this will be also x, and ultimately because of x pulley we are going to get a slack of 2x in this direction, and ultimately this entire thing will be 2x rather. So it means mass A will be moving in downward direction by a distance 2x, and let us say its velocity is VA, and we are going to find out what will be the relationship between VB and VA. Okay, so let us explain it in a more elaborative manner. You can say let mass B moves toward right by x, and with the velocity and with the velocity of Vb. Okay, then because of pulley x, there will be a slack of 2x. There will be slack of 2x in the string connected to mass A. And it moves with a velocity of VA. Okay, so it can be written in the form of equation as thus. We get VA, velocity of A, will be equal to 2 into derivative of x, that is dx by dt. Okay, and Vb, we already know that the velocity of B will be equal to dx by dt. So let us call this as equation 1 and equation 2. Using equation 1 and equation 2, we get VA we get VA is equal to, in place of dx by dt, we simply substitute VB. So we get VA is equal to twice of VB. So this is the relationship of the velocity of mass A with velocity of mass B for figure A. And in the similar way, we can find out for figure B also. And in this case, for figure B, we assume that mass A moves in the upward direction by a distance x, and mass A is connected directly with pulley X, or rather we can say mass A is connected at 2 points. So because of this connection at 2 points, what is going to happen? One extension or one slack will be x, and second slack will be 2x. So this slack will be only x, and this slack will be 2x. Okay, so total slack of B will be coming as 3x. Okay, so we can explain this part. You can say figure B let mass A moves in upward direction through x. Okay, but you can say but mass A is connected at 2 points. Okay, so let us say this point is called as first, and this point is called as second. Okay, 2 points, 1 and 2. Okay, the slack at point 1 will be equal to x, and the slack due to point 2 and pulley X is equal to 2x. Therefore, the total slack for mass B will be equal to x plus 2x, that is equal to 3x. Okay, and let VA and VB are the velocities for mass A and mass B respectively. Therefore, VA will be equal to dx by dt. Let this be equation 1, and VB will be equal to 3 dx by dt. Let this be equation number 2. So using equation 1 and equation 2, we get VB is equal to 3 times VA. So this is the relationship between the velocity of mass A as well as velocity of mass B for figure B as well. Okay. Thank you.